Alright, here's a quick explanation of number 4. This is just testing your basic exponential simplification properties. So remember, if we have a to the b plus c, that's the same thing as a to the b times a to the c. If we have a to the b times c, that's the same thing as a to the b to the power of c, or you could reverse the order, because we could have reversed the order of multiplication in the exponents here, and that would be the same thing. So when I look at a problem like this, I'm sort of pattern matching to this. I'm seeing e to the something plus something. I see those as blobs. So if I apply that simplification pattern, I can rewrite it as e to the natural log x squared times e to the natural log x, because I wrote a separate exponential statement for each of the exponents here. Now, I know that exponentiation and logarithms are inverses, so they undo each other. So this e to the power of undoes the natural log here. This e to the power of undoes the natural log. So I'm left over with x squared times x, or x cubed. All right, let's do the next one. If you don't remember what's the reason why these two things are inverses, why do they really undo each other, I'll review that in just a second at the end of the video. So second part of number 4, we've got e to the natural log x squared, like that, plus natural log x. So here I can start out in the same way. I see e to the blob plus blob. So I can rewrite this as e to the natural log x squared times e to the natural log x. These two cancel each other out, giving me just x. What happens over here? Well, I want to be careful about just mindlessly crossing things out. I want to think about what's actually happening. So what's actually happening is my exponent here is squared, which literally means times itself. So this is like natural log x times natural log x. All right. How does this part simplify? Well, here I can apply the rule a to the b times c is like a to the b all to the c power. So I'm going to rewrite this as e to the natural log x all to the power of natural log x. And I still have this times x on the outside. Last step, these two are inverses, so they cancel each other out. They undo each other. So that gives me x is the part on the inside, but that's still raised to the power of natural log x. And I'm multiplying by x on the outside, and that's as simple as I can make it. If you wanted to, this is the same thing as x to the first power, so I could rewrite it as x to the natural log x plus 1 by applying that same exponent property backwards. Those are the answers. All right, if you want to hear a short explanation about why are these two things inverses, stick around. All right, if you think about what do logarithms mean, this is this whole thing describes a number. Just the same way that like 1 divided by 2, this is an action. I'm saying divide 1 by 2, but this action also represents the result of the action. It also represents the value 1/2. So same thing here. This log base 2, I'm saying apply the logarithm base 2 to the number 8, but this also represents the results. It also represents a number. So what number is it? This represents the power of 2, which gives you 8. So I know that 2 to the third power gives me 8. Whoops, excuse me. So that means that this must be 3. If I said log base 5 of 25, that's what power of 5 will give me 25. The second power of 5 gives me 25. So if you use that thinking, let's think about this problem for a second. What if I have 2 to the log base 2 of 17? All right, so what is this number, this log base 2 of 17 up here? What is that number? That number is what power of 2 will give you 17. But then we're taking that power of 2 that gives you 17, and we're making it a power of 2. So I don't actually really even need to know what number this is, because it's defined as whatever power of 2 gives me 17. So when I make it a power of 2, I know the result must be 17, just by the way that I've defined the logarithm. So that's why exponentiation and logarithms are inverses. It's because they've been defined that way. If you remember, natural log of some value is just log base e of that value. So for the same reason, that's why e to the natural log of whatever it is equals whatever it is. It's because those two things are undoing each other. I'm saying this exponent is whatever power of e will give me blob. I'm taking that number and I'm making it a power of e, so the result is blob, which is the same thing as thinking about them just canceling each other out. All right, good luck.